Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Kuwati Mita Azadin, and today I want to present about experiment microwave optics 2SS6. The lecturer in charge is Dr. Nur Hafizah binti Madisa. This experiment is divided into 5 experiments. The first experiment is experiment 4, reflection through a prism. The introduction for this experiment is reflection is the change in direction of a wave passing from one medium to another medium caused by its change in speed. The loss of reflection is divided into two. First is the incident ray, reflected ray, and the normal to the interference of two media at the point of incidence all lie on the same plane. Second, the ratio of the sine of the angle of incident to the sine of the angle of reflection is the constant. This is known as Snell's law of refraction. And this is formula for Snell's law of refraction. And another formula is refractive index formula. Refractive index describes how fast light travels through the material. In this experiment, we will use the law of refraction to measure the index of refraction for styrene pellets. The equipment needed for this experiment is transmitter, goniometer, receiver, rotating table, ethnoform prism mold with styrene pellets, and protector. This is procedure for experiment 4. And the diagram shows a geometry of prism refraction. And this diagram shows a equipment setup for this experiment. And the second experiment is experiment 7, Lloyd's mirror. The introduction for this experiment is Lloyd's mirror is an example of phenomenon in which how a single electromagnetic wave can be diffracted into two waves, and when two components join back together, they form an interference pattern. The Lloyd's mirror effect is when a light from a monochromatic slit source reflects from a glass surface at a small angle. The reflected light then interferes with the direct light from the source, forming interference pattern. And the diagram shows Lloyd's mirror. An electromagnetic wave from point source A is detected at point C. Some of the electromagnetic wave, of course, propagates directly between point A and C, but some reaches C after being reflected at point B. A maximum signal will be detected when two waves reach the detector in phase. The equipment needed for this experiment is transmitter, goniometer, component holder, meter stick, receiver, fixed arm assembly, and one reflector. And this is procedure for this experiment. And another procedure. And this is diagram for equipment setup and transmission and reception points. For the next experiment is experiment 8, Fabry-Perot interferometer. The introduction for this experiment is when an electromagnetic wave encounters a partial reflector, part of the wave reflects and part of the wave transmits through the partial reflector. A Fabry-Perot interferometer consists of two parallel partial reflectors positioned between a wave source and detector. The wave passing through to the detector at any instant will be in phase and antiphase depends on the distance between the partial reflectors. And equipment needed for this experiment is transmitter, goniometer, two partial reflectors, receiver, and two component holders. And this is procedure for this experiment. And the diagram shows a Fabry-Perot interferometer. For the next experiment is experiment 9, Michelson interferometer. The introduction for this experiment is Michelson's interferometer split a single wave and then brings the constituent wave back together so that they superpose, forming an interference pattern. If the two waves are in phase when they reach the receiver, a maximum signal is detected. By moving one of the reflectors, the path length of one wave changes, thereby changing its phase at the receiver, and maximum is no longer detected. By moving a reflector a distance, wavelength over 2 will cause a complete 360-degree change in the phase of one wave at the receiver. This causes the meter reading to pass through minimum and return to maximum. The equipment needed for this experiment is transmitter, goniometer, two component holders, one partial reflector, receiver, fixed arm assembly, rotating table, and two reflectors. And this is procedure for this experiment. And another procedure. And the diagram shows a Michelson interferometer. And the last experiment is experiment 11, Brewster's angle. Introduction for this experiment is Brewster's angle is the special angle for incident that produces a 90-degree angle between the reflected and refracted ray. This formula for Brewster's angle, N1 is refractive index of the inertial medium through while the light propagates, and N2 is refractive index of the medium which reflects light. In this experiment, we will find that the magnitude of the reflected signal depends on the polarization of the radiation. No radiation will be reflected at Brewster's angle. The equipment needed for this experiment is transmitter, goniometer, polyethylene panel, receiver, and rotating table. And this is procedure for this experiment. And that's all from me. Thank you.